Good morning, everyone. It's my immense pleasure to welcome each and every one of you present here. It's such a wonderful moment for us to gather here at this majestic venue for the second day international conference organized by Department of Botany, St. Mary's College Autonomous Thoothukudi under the college scheme sponsored by DBT, Government of India, New Delhi. Prayer is a powerful tool that you can use to change your life. Let's seek our divine intervention through this prayer song. I worship you. I worship you. You are here. I worship you. I worship you. You are great. Promise, keep my light in the darkness. My God, that is who you are. You are waymaker, miracle worker, promise, keep my light in the darkness. My God, that is who you are. You are here, touching every heart. I worship you. I worship you. You are here, healing every heart. I worship you. I worship you. You are here, turning lives around. I worship you. I worship you. You are here, magic every heart. I worship you. I worship you. You are waymaker, miracle worker, promise keeper, light in the darkness. My God, that is who you are. You are waymaker, miracle worker, promise keeper, light in the darkness. My God, that is who you are. Now, I invite Dr. Daffodil, Assistant Professor of Botany, to welcome and introduce Dr. M. Muthukumaran, Assistant Professor. Chennai.
Good morning to all. It's with great pleasure that I extend my warmest greetings to each and every of you. Diverse backgrounds, to express our deepest gratitude to the Lord Almighty, the source of all knowledge and wisdom, for granting us this opportunity to come together again and engage in an enriching exchange of knowledge and ideas. At this juncture, I am pleased to introduce Dr. M. Muthukumaran, an esteemed expert in the field of plant science, particularly algal biotechnology. Dr. Muthukumaran completed his academic journey with a distinction, attained his BSc, MSc, B.Ed, MPhil, and PhD in botany from the University of Madras. Currently, he is serving as an assistant professor at the PG and Research Department of Botany in Ramakrishna Mission, Vivekananda College, Autonomous, Chennai. Dr. Muthukumaran brings over 14 years of rich teaching and research experience to this role. His doctoral research title, Studies on the Phytoremediation of Industrial Effluents and Utilization of Algal Biomass, highlights his profound contribution to this field. Dr. Muthukumaran's expertise spans various aspects of algal biotechnology, including algal culture collection, isolation, identification, and mass cultivation. Notably, he possesses specialized knowledge in biological wastewater treatment and effluent reuse with practical experience in industries such as oil drilling, dyeing, detergent, electroplastic, soft drinks, and pharmaceuticals. His work extends to the utilization of algal biomass for biofuel, pharmaceutical, biofertilizer, and other valuable byproducts. He is familiar with the freshwater algae of South India and has a sound knowledge of limnology and various other fields, which are very much related to the algology and environmental science. Throughout his career, Dr. Muthukumaran has been recognized with numerous prestigious awards for his outstanding contributions. These include the Best PhD Thesis Award in Botany, that is Professor K. Kalyan Sundaram Memorial Prize in 2010. The Appreciation of Good Service Merits Award for the year 2014 from the Award Board, Government of Tamil Nadu, Chennai. Young Scientist of the Year 2016 Award, Best Oral Presentation Award in 2017, Best Educationist Award for Talented Person in 2017, Environmental Biologist of the Year Award in 2017, National Teaching Excellence Award in 2017, Fellow Academy of Environment and Life Science in 2017, Eminent Young Scientist Award of the Year 2017 Award, and Dr. APJ Abdul Kalam Award in 2018 for Excellence. Leading Educationist of India Award in 2018, Bharat Excellence Award in 2018, and Best Indian Golden Personalities Award in 2018. In addition to his academic achievements, Dr. Muthukumaran has an extensive record of participation in 39 professional training programs, 188 conferences, symposia, and webinars, both nationally and internationally. He is also an accomplished author with 75 research articles published in reputed journals, 7 chapters in books, and 2 editorial contributions. He has 2 patent designs, and he was invited to present 10 special lectures in the national and international conferences. Dr. Muthukumaran is a dedicated member of various scientific organizations, including the International Water Association, International Phycological Society, Indian Science Congress Association, and Indian Botanical Society, National Academy of Biological Science. His biographical notes have been published in prestigious volumes such as Asia Pacific Who's Who, Volume 16 by Rifasimantur International, New Delhi on November 2017, and Porugi Kalvi, Volume 6, Issue 7 on August 2017, Chennai, Tamil Nadu, India. With his wealth of knowledge and experience, Dr. Muthukumaran continues to make significant contribution to the field of algology and environmental science, inspiring colleagues and students alike. We are very fortunate to have him as a resource person for this session. Please join me in extending hearty welcome to Dr. Muthukumaran as we embark on this enlightening journey together. Welcome you, sir. On behalf of our department, I also welcome distinguished faculty members from other colleges, research scholars, and student participants. Once again, I welcome you all to today's session. May our time together be enriching, inspiring, and transformative. Thank you.
Thank you, ma'am, for your warm words of welcome. Now, may I invite Reverend Sister Dr. Arokya Genesius Alphonse, Head and Associate Professor of Botany, Overall Star College Coordinator, to honor Dr. M. Muthukumaran with a memento. Thank you, sister. Thank you, sir. Sir, then kindly take over the session.
Good morning to one and all. First of all, I would like to thank the organizer of this international conference, given me an opportunity to share my research findings. I'm going to present my topic entitled Potential of Microalgae for remediation of industrial effluents and its applications. Next slide. The major issues which are related to the environmental pollution are becoming more dangerous with the growing of population, industrialization, urbanization, and the indirect toxic substance mixed into an ecosystem. The large amount of pollutant is present in the industrial effluents that harmfully conversion in the water resources are one of the major causes of an ecological pollution. Generally, the biological agent abundantly present in the nature to treat the various industrial effluents, one among microalgae also. Next slide, please. Conventional method. Conventional method versus algae technology, that means phycoremediation. All the industrial effluents are conventionally treating using a variety of hazardous chemical for the correction of pH, removal of sludge, color and odor. The extensive use of chemical for effluent treatment result in large amount of sludge which forms the so-called hazardous solid waste generated by the industry and finally deposited by depositing them in landfill. But algae technology avoid use of such chemicals and the whole process of effluent is very simplified. And there is considerable reduction in sludge formation also. The algae technology is highly cost effective and eco-friendly. Next slide. Objective of my presentation: to study about algal flora of in and around effluent treatment plant of various industries, isolation of microalgae from in and around ETP site of various industries, screening of microalgae in phycoremediation of effluent and sludge from various industries, effect of algal treatment of various industrial effluents on sludge, both laboratory and field experiment, analysis of various physiochemical parameters and various biochemicals, generation of valuable algal biomass, financial benefit to the industries, environment impact assessment, and utilization of algal biomass for various applications. Next slide, please. Experiment result: screening of the various effluents and sludge using microalgae. The feasibility study was conducted by growing 11 microalgal species in the all industrial effluents and sludge. The feasibility study, the microalgae better potential were selected for further investigation. Next slide. Occurrence of algae in an electroplating industry ETP waste and effluents. Totally 8 genera and 8 species belong to 3 families of Chlorophyceae, Bacillophyceae, Mixophyceae were identified. Next slide. In the textile industry, totally 23 genera and 29 species belong to Chlorophyceae, Bacillophyceae, Mixophyceae, Mixophyceae were identified. Next slide. Next slide. Algae occurred in and around the oil drilling industry. On whole 38 genera and 49 species belong to 4 families of Chlorophyceae, Bacillophyceae, Mixophyceae and Mixophyceae were identified. Next slide. Next slide. The experiment raceway pond study. The outdoor experiment was conducted in a raceway cultivation pond constructed in our college premises. The pond was constructed with a wall thickness of 25 centimeter. The inner dimension of the pond were such that the length of 365 centimeter and the width of 28 centimeter. The depth of the pond was kept at 45 centimeter, keeping in mind the sufficient light penetration for the growth of algae. A partition wall was constructed in the middle of the pond with a length of 246 centimeter and width of 12 centimeter. The floor was constructed with a slight slope on either side of the partition in the opposite direction to enable proper mixing of the culture. Next slide. This slide shows that the experimental ratio of pond dimension already explained. Next slide. For the pilot plant trials of microremediation, a high rate algal pond was constructed inside the industry premises, and the dimension was same as that of the research pond constructed in the pilot premises. Next slide. Diving industry effluent sloping pond. The pilot sloping pond was constructed in reinforced concrete cement tank and was designed with a dimension of 268 centimeter length, 238 centimeter width, and 64 centimeter depth, with a sloping angle of evaporating rate surface at 150 degree. The dimension of the slope area was 2.53 meters square. The flow rate of the effluent was maintained at 59 liters per day. 1 centimeter of water is the tank equal into 63 liter, and the plant was run during the day for about 9 hours. Next slide. This picture shows that the schematic diagram of the sloping pond, which was constructed inside the industry. Next slide. The nature of the effluent and sludge from the electroplating industry. The electroplating industry effluent are both in acidic and alkaline. The acidic effluent contain heavy metal like chromium, nickel, cadmium, and high total dissolve, and so on. Alkaline effluent is generated from coating of the paint to wheels. This effluent contains calcium chloride and heavy metal. The sludge is rich in heavy metals, especially for chromium. Next slide. Chrome sludge from an electroplating industry. Based on the preliminary study, the potential microalgae Desmos olivaceous showed a better survival in the 0.2% of chrome sludge concentration than the other microalgae. So it was selected for further field experiment in open reservoir pond, and the microremediation of the sludge was carried out. Total dissolved solid and sludge showed a gradual reduction and cell count was increased. The effluent was analyzed and the reduction percentage was calculated. Next slide. This video and picture clearly shows the Desmos olivaceous growth in chrome sludge of electroplating industry in open reservoir pond. See the before treatment and after treatment. Next slide. A comparison of the various parameters of raw and algal treated electroplating industry probe sludge in open reservoir pond. Almost all the physicochemical parameter was significantly reduced, especially for total dissolved solid. Next slide. Chloride, phosphate, and chromium, and better BOD COD level also. Next slide. Next slide. Next slide. Algal biomass production by Desmos olivaceous grown in open reservoir pond. The research shows that on 10th day, the algal biomass production was in high percentage. Next slide. The sludge removal efficiency of Desmos olivaceous grown in electroplating chrome sludge in a pilot tank study. The results showed that there was a considerable sludge reduction around 20% when cell count of Desmos olivaceous was also found to be maximum 380 to 12% per month on 10th day. The grown algal culture was harvested and biochemical parameters were analyzed. Actually, the nature of textile dyeing industry effluents. The textile dyeing industry generate two types of effluents. One is a combined dyeing effluent, another one is a dye-bath effluent. The effluents generated from various sources like dye-bath, mercerizer, wash water, de-icing water, and printing. The industry generates around 200 kL of effluent per day. The effluent is treated with the conventional physical and chemical method, resulting in large amount of sludge and water effluent. The dyeing industrial effluent is rich in various dyes and high pH and total dissolved solids because of various chemicals being used like sodium bicarbonate, sodium chloride, and so on. Next slide. This flow chart shows the conventional process of textile and sources of effluents. Next slide. The growth rate of various microalgae in textile industry combined dyeing effluent. The research shows that the chlorine showed a better growth rate of 0.38 division per day when compared to other microalgae. So this alga was selected for further field experiment. Next slide. The growth rate and color removal efficiency of chlorofluorocarbon in textile and industrial combined dyeing effluent in lab condition. The result shows that the growth rate was 0.29 division per day, 62% of color removal, and cell number was 452 into 10 to the power 4 cell per ml. Next slide. The periodic analysis of various parameters like pH and total dissolved solids in pilot scale tank with textile dyeing industry combined dyeing effluent using chlorofluorocarbon. Next slide. The result shows that. Next slide. The pilot scale study, the effluent around 59 liters was added according to the evaporation rate. The chlorofluorocarbon with the average cell number of 262 in 10 to the power 4 cells per ml was able to remediate the effluent with a sludge reduction around 62% and maintain the average pH of 9.6 against control pH 11.7. Next slide. This picture shows the effluent treatment plant and microremediation at textile industry. The raw effluent collected tank, the settling tank to remove sludge after chemical treatment, and last one is a microremediation pilot tank. Next slide. After successfully applying the microremediation of textile dye industrial effluents, the grown algal biomass was harvested by the cost-effective method of by filtration or by settling or using bioprospecting. The last slide, last picture shows that the production of dried algal biomass for further various biochemical analysis. Next slide, please. Microremediation efficiency of chlorofluorocarbon in textile dye combined effluent under lab and field condition. A comparative study. The result shows that almost all the parameters are significantly reduced when alga treated effluent in the field condition, especially next slide, especially turbidity, total dissolved solid, calcium, ion, and the better DOD COD levels. Next slide. Next slide. Growth and color removal efficiency of chlorofluorocarbon in textile dyeing industry diaphragm effluent under lab condition. The result shows that the growth rate was 0.1 division per day, 10% of color reduction, and the cell number was 280 in 10 to the power 4 cells per ml. Next slide. Periodic analysis of various parameters in pilot scale tank with textile dye industrial diaphragm effluent using chlorofluorocarbon. Next slide. The result shows that the significant level of next slide. The significant level of sludge reduction was around 53%. Next slide. The microremediation of the textile dye industrial diaphragm effluent in lab and field condition in a comparative study. The result shows that all the parameters were significantly reduced when alga grown in diaphragm effluent in the field conditions, especially total dissolved solids, total suspended solids. Next slide. Potassium, alkalinity, chloride, and better DOD COD levels. Next slide. Next slide. A comparison of alga treatment with the conventional treatment. The first tube shows that the raw effluent loaded into the treatment plant. It is a darky color due to dyes highly alkaline, the pH around 11.4, with a high total dissolved solid around 6,800 mg per liter. The second tube shows that the effluent treatment with conventional chemical treatment, the pH is around 9.6 and total dissolved solids around 10,280 mg per liter, which is much higher than the raw effluent due to usage of chemicals for the treatment and sludge removal is 100%. The last tip shows that the effluent treated with an algal technology, the pH is corrected to 9.5. The total dissolved solid is reduced around 5,700 mg per liter. And there is excellent color removal also. There is a significant reduction in sludge which can be improved when scaled up. An average sludge reduction in textile industry combined dyeing effluent and diaphragm effluent treated with chlorofluorocarbon and a pilot tank study. The results show that 62% of combined dyeing effluent and 53% of diaphragm effluent respectively. Next slide. The nature of effluent from an oil drilling industry. The oil drilling industry effluent has higher inorganic chemicals from oil separation process which utilize hydrochloric acids, X, sodium bicarbonate, and so on. The effluent is high total dissolved solids. Next slide. The slide shows that the actively grown algae on the surface of oil sludge from the oil drilling industry. Next slide. The growth rate of various microalgae in oil drilling industry effluent. The research shows that the chlorofluorocarbon showed a better growth rate of 0.24 division per day when compared to other microalgae. So This alga was selected for further field experiment. Next slide, please. Next slide. Effect of oil drilling industrial effluents loading in a pilot scale treatment using microalgae. Effluent was added periodically 100, 200, 300, and 600 liters per day with a continuous flow from 8 a.m. to 6 p.m. by drop by day throughout the day. The pH, total dissolved solids, and cell number were noted regularly. Raw effluent had pH around 6.1, which showed slight increase in pH around 7.3 after treatment with alga. After treatment, the effluent showed a tremendous sludge reduction around 69%. Next slide. This picture shows that the pilot scale tank in oil drilling industry. Next slide. A periodic analysis of various physicochemical parameters, especially for pH, TDS, and cell number in oil drilling industry effluent treated with the chlorhexidine, a pilot scale experiment. The results of that. Next slide, please. Next slide. Next slide. The significance reduction was around 69%. Next slide. This video graph shows that the scale of tank entire view of oil drilling industry. Next slide. Scale of tank slope surface structure. Next slide. Scale of tank phycoremediation of oil drilling industry effluent using chlorhexidine. Next slide. The first picture shows that the sludge degradation of chlorhexidine in bottom of the scaled up tank. The next picture shows that the grown algal biomass was harvested from scaled up tank. Next slide. The periodic analysis of various parameters in oil drilling industry treated with the chlorhexidine and scaled up tank. The results show that. Next slide, please. Next slide. The significant sludge reduction was around 47%. Next slide. Next slide. Microalgae of microalgae in oil drilling industry effluent, a comparative study. The results show that all the parameters were significantly reduced in scaled up tank algal treatment when compared to pilot scale and lab trials. Next slide. Next slide. This picture clearly shows that the untreated raw effluent and the treated effluent of pilot scale and large scale tank. Next slide. Next slide. pH changes in oil drilling industry effluent treated with chlorhexidine, a comparison of pilot slope tank and scaled up tank. A scaled up slope tank. The result showed that an average pH of raw effluent was 6.1. The treated effluent of pilot slope tank around 7.3 and scaled up tank was 7.8. Next slide. Environment impact assessment. Any effluent treatment method should be safe to the environment and hence the environment safety credential of phycoremediation using chlorhexidine were assessed. Next slide. The effect of chlorhexidine on germination of the lycopodium. The result shows that the treatment with an alga chlorhexidine cells improved the germination of seeds tested. That is, the total length was more by nearly 40% when control of 21%. Next slide. The effect of chlorophyll treatment on the chlorophyll content of Ixora toxina. The result shows that the chlorophyll content was increased around 73% when alga treated plants. Next slide. The effect of chlorofluorocarbon feeding on golden fish. Next slide. Next slide. Next slide. The result shows that the chlorofluorocarbon alone was used as a fish feed. The weight of the fish showed an increasing tendency, that is 3 gram per fish, around 31% and an average, when compared to the weight of the fish with the commercial feed alone, that is 2.8 gram per fish, around 29% and an average. Next slide. Next slide. Next slide. Next slide. The value-added biochemical properties grown in lab and field conditions of textile dyeing industry. Almost all the biochemical content were significantly increased when alga grown in dyeing industry effluents. Especially, the lipid content was very high, around 45% when alga grown in dye bar effluent, which suggests that it is highly suitable for biodiesel productions. Next slide. Utilization of algal biomass for various applications, especially for biodiesel production of chlorhexidine. The search for an alternative means for mass production of algae ended at phycoremediation plants. Here, algae grow in a highly versatile environment. The algae chlorhexidine did survive well in this effluent, tolerating stress conditions like very high total dissolved solids and adverse pH condition producing high lipids. Next slide. This picture clearly shows the lipid extraction from the chloromethanola grown in lab and field conditions. Next slide. GCMS analysis of algal oil extract from the chloromethanola. The result shows that the total 91 to 94%, which suggests that it is highly suitable for biodiesel production. Next slide. The standard firm report. Next slide. Alga grown in combined diaphragm. Next slide. Alga grown in diaphragm. Next slide. Energy from algae. The chloromethanola absorb carbon dioxide, release oxygen, and generate electron during photosynthetic period. The electron have vast potential microbial fuel cell to give electric power. The microalgae fuel generate more power with an alga grown in scaled up tank than the alga grown in pilot tank. Next slide. This picture shows that the microalgae fuel cell using oil and industrial plates with mediator and without mediator. Next slide. Caloric value analysis of chlorohemicol algal biomass pellet. Algae growing on industrial plate are harvested and dried. These dried algae, with the help of the pelletizer, were converted into pellet. Caloric value analysis was performed using this algal pellet. Next slide. This picture shows that the pelletized dried algal biomass chlorohemicol. Analysis of dried chlorohemicol for TGA, DTA, and DSC. Next slide. Next slide. Next. 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 The result indicated that the algal biomass pellet was high in caloric. Next slide. Next slide. Around 1.1 rupee cost saving from textile dyeing industry after successful running the bioremediations. Next slide. Benefit of bioremediation. So many benefits are there, especially for oxygenation of the environment and carbon dioxide sequestration, a solution for the threat of global warming. Next slide. Of textile dyeing industry clearance. Next slide. The data generated in the present investigation will be helpful in scaling up of this technology to manage textile dyeing industry effluent using chloromethanola. Apart from efficient nutrient removal properties, the chloromethanola showed appreciable sludge reducing potentials. The chloromethanola had effectively corrected pH and also decreased textile dyeing effluent in pilot scale study. GCMS analysis of chloromethanola showed 91 to 94% of total saturated fatty acids, which suggests that it is highly suitable for biodiesel production. In an oil drilling industry effluents, chloromethanola showed better growth, adjusted the pH, and reduced nutrients in appreciable levels. Next slide. An oil drilling industry effluents could be remediated with the microalgae with considerable amount of sludge reduction, both in pilot and scaled up. Chloromethanola impact assessment study to prove that the use of microalgae is safe and well. The right generate significant
Excuse me, kindly unmute and talk. Emma, सर ने क्या बोला? वही सुशीला, सर ने क्या बोला? जाके आ। हाँ, वही बोला मैं। आप इसमें लेना वो लोग। वही बोला। वो एक दिन ऑफिस गया ना, पूरा दिन वेस्ट होता। Hello, is there conference going on or you have closed it? We could hear nothing, we could see anything. What is happening?